Hello and welcome to a lesson on an introduction to problem solving. So as we further our mathematical careers and we move into algebra, we need to be able to identify keywords and the operations that connect with them, because ultimately the purpose of math is not to, add, subtract, multiply, and divide for the sake of doing so. It's so that we can apply the math to new situations or to real life situations. And real life situations show themselves in math classes as word problems. Okay, and those are only going to be possible for us if we have a basic understanding of the problem solving process, what's going to make us successful there, and what key words are going to clue us into specific operations. Okay, so let's talk about a general strategy for success. And what makes word problems difficult is that there isn't one way to solve every single word problem, but there is one strategy that we will discuss. So the first thing that we need to do is we need to understand the problem. And coming to an understanding could require several things. Usually it's read the problem, maybe even reread the problem, okay? Read and reread. Maybe read it 3 times. Read it as many times as necessary for you to understand what it's giving you and what it's asking for. If it's helpful, maybe you want to draw a picture. If you're talking about a rectangular garden, for instance, we could draw out a rectangle, right? We want to look for keywords, and the keywords that are going to give us certain operations we'll talk about in just a few minutes. And again, identify an operation. Are we solving? What are we doing? Okay? So we need to understand the problem. And then what we're going to try to do is translate it. We're going to try to take the words and make them mathematical. Take the words that mean operations and make them mathematical operations. Can we make an equation out of something that we can try to solve? So we'll start by writing it in short form. So we may have a paragraph of words that we have to condense down to something shorter, and then from the short form, a direct translation using symbols and numbers. Okay? Once we have a translation, then we can solve. And the solve will be adding, subtracting, multiplying, dividing. It's going to be one of our basic operations. It might be helpful to estimate the solution that we're looking for by rounding first and then actually carrying out the indicated operation, but in either case, we got to solve. And the last thing is we want to interpret our results. Interpret our results. Did we get an answer that makes sense for our problem? So we can check it, work backwards, make sure that it works. And then if we have units or some appropriate way to answer the question, let's make sure we have answered it appropriately. Okay? So understand it, translate it, solve it, and then interpret to make sure we have a reasonable and sensible solution. Okay? So the translating part is probably the hard part, because there are lots of different words that we're going to see, and we got to know their meanings. So for instance, if we're looking for addition, if we're trying to identify addition in a sentence, we're looking for words like sum, or added to, or plus, or more than, or total, or increased by. If we're looking for subtraction in a word problem, then maybe we see difference, or subtracted from, or minus, or less than, or take away, or decreased by. If we're trying to identify multiplication, then maybe we see times, or product, or just the word of, or multiply by, or double or triple. That would be multiply by 2 or multiply by 3. If we're trying to identify division, it could be quotient, ratio of, per, like 1 per student, divide, shared equally, or divided by, or divided into, all imply division. And then lastly, if we're trying to identify equality, that's an equal sign. We might see the word equals, or is equal to, or just the word is. That's probably a big one there. Or was, or yield, or makes. And I'm sure there are things that I've left off the list there, but those are the big ones. Okay? So we're looking for words that give us operations. So I have started here with a few short form. Right? This is where our word problems are already in short form, so that we can go just to translating and practice that. And then as we progress, we're going to get to a longer problem, try to write it in short form ourselves, and then try to solve. Okay? So if we look at this first example, short form, it says 12 increased by 17 is what number? So if we were to translate this, there's nothing to translate. 12 is 12. Increased by. Okay, when we see increased by, that means added to it. Okay, 12 is increased by, or something is added to it, and it's increased by 17. So 17 is going to come down here. And then our word is, that is our equal sign. And then what number? Since we don't know, maybe that can be our question mark. Okay? And later when we get to algebra, that's where we might introduce something like a variable, but I don't want to go crazy and put any variables in here yet. So this what number we don't know, we're going to try to figure that out. So 12 plus 17 equals what number? Well, now we just got to add 12 and 17. So 12 plus 17 makes 29. So our missing number is 29. That is the solution for this problem. Hopefully that wasn't too terrible. Okay? So let's look at the next one here. It says, what is 8 multiplied by 9? So what, we don't know, let's call that a question mark, is, that's our equal sign, and then it says 8, which we don't need to translate, that's 8, and then it says multiplied by, so 8 is going to be multiplied by, and then it says, I need another color, no, I already used that one, by 9. So we're going to bring 9 down. I'm sorry, that's a bad color. Okay. What is 8 multiplied by 9? Well, we're going to figure that out. We're going to answer our question here. And so 8 multiplied by 9 is 72. That means the answer to our question is 72. Okay. Not so bad. Let's keep trying here. So 3 says, what is the quotient of 1,280 and 5? So what? That is our question. Is, that is our equal sign, and then it says the quotient of. The quotient of means we are dividing two things, and we can use our division symbol or we can use a fraction bar. I'm going to stick to the division symbol. Actually, I'm going to use a fraction bar. Although it doesn't matter, they're the same thing. We need a fraction bar, and it's a quotient of, the question is what goes on top of the fraction and what goes on the bottom. So the first number given to us is the one that's going to be divided. That is our dividend. That's going to be the top of our fraction. And then the next number given to us, that's our divisor. That is the bottom of our fraction. So what is the quotient of these two numbers? Means we have to divide these two numbers to get our result. So our result's going to be, I'm going to do a little long division here, 1,280, although feel free to use calculator. 5 is going to go into 12 twice. 2 times 5 is 10. When I subtract, I get 2. Bring down the 8. 5 goes into 28 5 times. 5 times 5 is 25. I'm going to subtract to get 3. And then if I bring down the 0, 5 goes into 30 6 times. So this is going to be 256. I'm going to leave my work here. So our missing number, the answer to this question is 256. Alrighty. Okay, and again, if you wanted to just use your calculator, by all means, put in 1,280. I just want to check my work. Divide by 5, and there it is, 256. Okay? Alright, how about this next one? It says, what is the total of 45 and 8? So what, question, is equals the total of means we have to add two things, and it's the total of 45 and 8. Not enough colors here, and 8, so we want to add the 45 and 8 to get that total. So 45 and 8 is going to make 53, our answer here. I don't know why I'm putting equal signs sometimes and not other times, but technically, actually, I don't want to clog up my paper. So 53 is our answer on that one. Okay, how about this one? What is our question? What is, that's our equal sign, the difference of. The difference of means we need to subtract two things. And we're going to be subtracting 24 and 6. So if we subtract 24 from 6, we are finding the difference of those two numbers. What is that difference? 24 minus that 6 gives us an answer of 18. Okay? And here's another. And at any point, if you feel like you're good, feel free to pause the video to try these things out yourself before you just let me ramble on through the answer, okay? And then you can always unpause and see if you did it correctly. So 65, nothing to translate there, 65 is 65, is decreased by. That means we are subtracting from it. It's decreased by 12. So I'm going to take, actually I don't want to use that there. We're going to take 12 away. So 65 decreased by 12 means 65 minus 12. And then is, and this is our question. It is what? What number? We don't know, so that's the question. So we're going to answer the question by finding or performing this mathematical operation. So 65 minus 12 makes our answer 53 for this one. Okay, so the goal for the word problems that we're going to look at when we get to the back of our note page here is to write or condense, after we read and understand the problem, condense it down to one of these short forms so that we can translate and solve without too much issue. Okay, so number 7, here's an example. And some of you could probably do this without all the work that I'm showing, but for those of you that tend to struggle a little bit more, going through a methodical process hopefully will help, okay? So number 7 says that the Hudson River in New York State is 306 miles long, and the Snake River in the northwestern United States is 732 miles longer than the Hudson River. How long is the Snake River? So we have the Hudson River. I'm just going to draw this out, and I'm going to say this is the Hudson River. And we know that our Hudson River is, what does it say? Hudson River is 306 miles long. Okay? And then it says the Snake River is 732 miles longer. So our Snake River, let's call this the Snake, is got this much, and then it's 732 miles longer. So it's got what the Hudson River has, and then an additional, and you can see what's happening mathematically there, 732 miles. So how long is the Snake River? So we could say, if we were going to translate this, that this is just a crude picture here, but maybe helpful for you to see what's happening. I want to get rid of my picture now. My gosh. So we have, geez, now I lost my total train of thought. The Snake River, or the Hudson River, and, oh no, backwards. The Snake River, I'm sorry, is 732 miles longer than the Hudson, okay? And I think it even says that in there. That's 7. Oh, actually, it does say that in there. Why did I write all that? You guys are just letting me do this. Sorry. The Snake River is 732 miles longer than the Hudson River. So our question is, how long is the Snake River? Okay? So the Snake is 732 more than the Hudson. I think this would be a better short form. And you see how it took me a couple tries there. It might take you a couple tries too if you're trying to short form it. So, and some of you are like, I already have the answer. That's you. Cool. So the snake, let's try to translate there. We don't know, but it is, there's our equal sign, 732, nothing to translate there, 732, more than means add to the Hudson. And the Hudson, we know, I need a better color there. What did I not use? I've used all of these. The Hudson, we know from here, is 306 miles long, so 306. So how long is our Snake River? Well, we have to add the 732 and the 306, and let's just use the calculator. 732 plus 306 makes that 1,038. And that's the total number of miles in length for the Snake River. So 1,038 miles. And that makes sense. If I had 1,038 miles and I subtracted out the 732, there's the 306 that I started with for the Snake River. Or for the Hudson, sorry. Okay. I probably talked way too much on that one. Let me try again. It says 1 case of olives holds 48 cans. How many cases can be filled with 9,900 cans? How many will be left over? Will there be enough to fill an order of 200 cases? So we have a lot of questions here. But we have 9,900 cans, and we want to divide them into cases. That's what we're trying to do. And 1 case holds 48 cans. So we have 9,900 cans that are going to be divided into cases of 48 each. Okay, so 9,900 cans divided into cases of 48. 48. So that means we're going to take our 99 and divide. So 9,900 is going to be divided by 48. And we could see what happens. Is it going to divide evenly? 9,900 divided by 48 does not. So let's go ahead and do the long division here. If we take 48 and we go into 9,900, it's going to go in twice here. 2 times 48 is going to be 96. So that's going to leave us 30. Won't go into 30. So we're going to have 30 left, and then 300. So let's see, 2, 4, 6 times. And 6 times 8 is 48. If I carry the 4, that's going to be 288. When I subtract, I have 2 left over. So remainder 2. So if we go to answer all these questions, how many cases could we fill? Well, we can get cases of 48 exactly 206 times. So we can fill, this was 206, remainder 2. And just so I can fill my space nicely here, we're going to say how many cases can be filled. Let's call this question 1. We can fill exactly 206 cases. How many will be left over? Let's say question 2. There will be 2 cans left over. And then lastly, the third question was, will there be enough to fill an order of 200 cases? Yeah, there's enough because 206 could be filled here, so yes. We can fill more than 200 actually. Okay, so not too terrible. Just make sure you're answering all of the questions. And this one was here. And I suppose I could move all of this because now it's looking like a jumbled mess. Okay, and let's see. We got another one here. It says that the director of a computer lab at a local college is working on next year's budget. It says 33 new desktop computers are needed. typo, at a cost of $487 each. What is the total cost for these desktop computers? So computers, what is the total for, what is it, 33 computers that cost $487 each? That's the real question here, okay? So what, question mark, what is our question? Is the total, so the total for 33 computers that cost $487 each. So 33 computers at $487 each. $487 each means we have to multiply by 487. Okay, so we're going to get that total cost by multiplying. And I'm absolutely going to use the calculator for that, because the word problems are enough. No need to jumble it up with the math operations too. So we end up with a total of $16,071 total. That's a lot of money factored into the budget for desktop computers. Don't these people know that nobody uses desktop computers anymore? No, people use them, but not many people buy them anymore. Laptops are the computer of choice these days just because the mobility and flexibility is nice. Although I do miss a good old-fashioned large screen on a desktop. Okay, sorry. Not that you care. All right. In 2017, the average salary for a public school teacher in California was $69,320. That is much higher than Arizona. It says for the same year, the average salary for a public school teacher in Iowa was $20,370, less than that. What was the average salary for a public school teacher in Iowa? So if it's $20,370 less than what it was in California, less than means we have to subtract. So Iowa's salary, the salary in Iowa, is the California salary minus or less, come on, pen, 20,370. Okay, so Iowa was what we're trying to figure out. That's our question. Is California was 69,320, and then minus the, nothing to translate here, I've already used all my colors. Let's just go gray. 20,370. Okay, so all we gotta do is subtract to figure out our difference here. 69,320 minus 20,370 is 48,950. So that was the average salary in Iowa. Okay, it was $20,370 less than it was in California. And I would have ballparked, right? If it was about 69,000 in California minus about 20,000 in less in Iowa, this is about 49,000 is pretty close to what we are. So that process of estimating could be helpful just to make sure you're getting to a reasonable answer. But that's a lot less. The cost of living, though, in Iowa is tremendously less than it is in California. Sadly, though, that average salary in Iowa is still far exceeding what the average salary is for a public school teacher in Arizona. I haven't looked recently, but last I checked, which was a couple of years ago, I had a friend that was going into the field teaching high school, and we researched, and the average salary in Arizona a couple of years ago was like $36,000 a year, so kind of sad. Maybe we've made headway since the Red for Ed movement, I'm not sure. But don't feel too bad for us college professors. The pay isn't too bad, but that's because we're not public school, okay? Anyway, that'll do it for today. I think you have enough problems to get going. However, if you find yourself needing any help, then just reach out. All right, take care.